Greetings to grade 11 and grade 12. This is Mr. Ntuli from the other side. I wish to greet you with this special note that you are a blessing. You are blessed as you are going to watch this video, and you are blessed as you are going to continue and finish watching this video. This is a blessing indeed, and continue to be a blessing. I wish you to shine in each and every area of your life. Right, guys, today we will be looking at grade 11 theorem 2, which is the angle at the center. I'll also introduce a diameter which forms a semicircle, and also we will be looking at the problems based on the exam type question. Now, as we are looking at the angle at the center, let us do some little bit of investigation so that we can understand on what we are talking about. Right. On this theorem, we'll be looking at the angle that will be formed at the center. Let us draw the angle. Right. And we will investigate that angle with the angle that it formed at the circumference. Okay. Now, let us do some magic to measure this angle with the angle at the circumference. Okay. Let us measure this angle which is at the center. It gives us 107 degrees, 2. Let us also measure the angle that is subtended at the circumference. It gives us 53.6 degrees. What can you tell me? This angle is twice the angle at the circumference. Okay. Let us check when we adjust this angle. Okay, let us take it closer to 150. Close to 150. Do you see that if this angle is 150.4 degrees, this one is 72.2. It means this angle is twice the angle at the circumference. And lastly, let us check now if this angle is 180 degrees. If it's 180 degrees, I hope you agree with me that that line now will be a diameter. If it's a diameter, then this angle now, it has to form what? If this angle is 180 degrees, then I hope we can see that it forms 90 degrees, of which we can conclude that a diameter is subtend 90 degrees at the circumference, which is a semicircle. Okay, guys, now let us look at this problem now. This is question 3, which is adopted from 2020 from Eastern Cape, grade 11. For exam purposes, you will be given a diagram and then you will be asked to prove that angle AOB is twice angle 2CB. Is twice angle 2CB. Okay. Now, if you remember very well on my first video, I said you need to do a construction because there's a mark for construct. What we are going to do, we will join line CO, then we can extend our line to call it D. It means we will join COD. We'll join line COD. If we join line COD, I hope you understand that it formed angle O1 with angle O2, and same with C1 with C2. Okay, guys. As we were constructing I hope you noticed that CO is a radius, which OA is also a radius. What can you remind me about radius is that they form an isosceles triangle, and then these two angles will also be equal. We'll use that as our advantage. Guys, for this theorem, I want you to remind yourself with these two things that we spoke about when we introducing this diagram. If you forgot, can you please go back to my previous video and check what we're talking about. Right, if we have an isosceles triangle, we said this angle has to be equal to this angle. And if I have an exterior angle, this angle plus this angle, theta is equal to beta plus alpha. This is what? An exterior angle of a triangle. And for an isosceles triangle, we say equal angles, opposite equal side. We'll use these two things on this theorem. These are very important. Okay, guys, let us go back to our question now. We did construct line COD, and we have an exterior angle which is O1. It means O1 is equal to angle C1 plus angle A. What is my reason? Date on top would say exterior angle of a triangle. But let us use this principle now, B, but angle C1 is equal to angle A. Why we say so? It's an equal angles, opposite equal side. Okay, then it means instead of angle A, I can substitute with angle C1 because these two angles are equal. Therefore, angle O1 is equal to angle C1 plus angle C1 again, because these two angles are equal. Then take out the common factor of C1, it means C1 is equal to 2C1. We can do the same thing with O2 and C2, but we can just say similarly O2 is equal to 2C2, right? Then, initially, I was talking about the angle O as a whole. It means let me add O1 and O2 so that I can get back my angle O. It means I will say angle O1 plus angle O2 is equal to 2 angle C1 plus 2 angle C2. Okay, what is O1 plus O2? It's A, O, B. You agree with me? It's A, O, B. What is 2C1 plus 2C2? Take 2 as a common factor, and it should be 2A, C, B. Right. That's how we prove this theorem. Okay, but to remind yourself that we used an exterior angle of a triangle and also the isosceles triangle, which is equal angles, opposite equal side. Then we'll be able to prove this theorem. But before we proceed from this theorem, I want you to remind you guys that this theorem, it can also be used in terms of a diameter. If this is a diameter, if you saw my demonstration, we said a diameter subtend 90 degrees, which is semicircle. And please, guys, this theorem, it also works that if this is your angle, then it should be twice this angle. Please make sure that you don't forget that. Okay, right. Let us proceed now to the problems and check how we can use this theorem so that you can be able to solve the problems. Now, this problem is also taken from the above problem that we're doing. And then we were given a diagram. Please grade 10, grade 11, and grade 12. When you have been given a diagram, make sure that you read the given statement, you analyze your diagram before you go to the questions. In this figure below, see this CO is 25 degrees, there is 25 degrees, okay? And O is the center. Wait a minute. If O is the center, check for the radius. Check for a diameter. Right? OC is a radius. OD is a radius. It means if this is 25 degrees, and also this will be 25 degrees. Right? And then, in short, you can say equal angles, opposite, equal sides. Just to remind yourself. Okay. Right. If this is a center, okay. Okay. Also, this it's a radius. You have theorem number 2. Yes, there is theorem number 2. This is your angle, and it's twice the angle at the circumference. Once I know this angle, I'll be able to find this angle which is at the circumference. Okay. Let me continue with my statement. A, B, E, C, and D upon circumference. Calculate given reason the sizes of. And lastly, if I have these two angles, don't forget your exterior angle of a triangle. Don't forget your exterior angle of a triangle. Okay, guys. Right. Let us proceed now to the problems. Problem number 1 say, calculate the size of D1. Wow, D1. Oh, okay. We said D1 is equal to 25 degrees. D1 is equal to 25 degrees. Why we said so? Because it's equal angles, opposite, equal sides. Okay. And then show that 25 degrees on your diagram. Calculate O1. O1. Wow. O1 is an exterior angle of these two angles. Right? It means to find your O1, it will be 25 plus 25. What is the reason? It's an exterior angle of a triangle. Therefore, O1 is 50 degrees. Put 50 degrees instead of O1. Lastly, find A1. Wow, A1. Come on, guys. Angle at the center is twice the angle at the circumference. It means if O1 is 50 degrees, therefore angle A1 would be 25. It means angle A1 is half angle O1. Why? Angle at center. Okay. Right. Then O1 is 2 times angle A1. Why? It's angle at center 2 times angle at circumference. Okay. Then A is 50, 2 times A1. Therefore, A1 is equal to 25 degrees. Okay. And A1 is equal to D1, which is also called what? A same segment. But we'll talk about that when we are doing cycle quadrature. Okay, I hope you understood. If you didn't understand, pause the video and go back and check. Right, guys, let us look at 4.3. 4.3 was adopted from previous paper, which was April 2021. Okay, first thing first, read your given statement. O is the center of the cycle. There is O, which is the center of the cycle. It means OE is a radius and OA is also a radius. Just indicates, it means this angle is equal to this angle. Just in case if they want you to use those principles. If again O is the center of the cycle, let me check for theorem number 2, angle at the center. I have the angle at the center, which is COE. Wow, it is twice angle A. There is angle A. COE, there is angle A. Again, it is COE, it's still twice angle B. Okay, just in case if they ask me anything. It means since this is 130, therefore I can be able to find this 65 degrees. Now, BE is parallel to CD. Wait a minute. If this BE is parallel to CD, you need to remind yourself 3 things are under parallel lines, which is your fan, right? Which is your fan. Okay. What you know about fan is that we have corresponding angles, co-interior angles, and alternating angles. Okay, right. Take note of that. Now, angle O1 is equal to 130 degrees. Let us check now how we can find our sizes. Calculate angle B. Calculate angle B. There is B. Come on, guys. B is twice angle O1 because we have an angle at the center. It means my angle O1 is 2 times angle B. If what is our reason? Angle at center then we set O1 to 130. Therefore, angle B is equal to 65 degrees. Let us look for angle A. Wow, there is angle A again. Angle A, we still have an angle at the center, which is twice the angle at the circumference. It means angle A again is also 65. It means angle A is equal to half angle O1, angle at center. Okay, which is half 180, which is 65 degrees again. Right. Let us look for angle D. Again, angle D is here. Okay, angle D will be twice the angle at the circumference, will be twice the angle at the center, but this is the angle that will be twice the angle at. It means I need to find the value of this angle first before I can find the angle D. Okay, it means let me start by looking for this angle, which I can call it angle O3, which would be 360 minus 130 degrees. Okay, which would be 230 degrees. Then, this is what angles around the point. Then, it means angle D is equal to half angle O3, angle at center. Then, what is angle O3? It's 230. It means angle D will be 115 degrees. Okay. And another way of finding angle D is that when we'll be dealing with cyclic quadrilateral, you will notice that two opposite angles of cyclic quadrilateral are supplemental. It means if I add angle B plus angle A, it has to give me 180. And since this is 65, yes, 180 minus 65, it is still 115 degrees. But don't worry, we'll use that principle after we are done with cyclic quad. Right. The last thing now is to find angle E1, is to prove that angle E1 is equal to angle E3. Okay, let's just clear this thing out. Right, guys. Now we've said that, let us find now the last problem. We need to prove that angle E1 is equal to angle 3. Okay. Now, where is angle E3? There is angle E3 and there is angle E1. We need to find a relationship between these two angles. But if I look at angle E1, it has a relationship with angle A. It means angle A is equal to angle E1 plus angle E2. You agree with me? Because of what? Equal angles opposite equal side. It means we have 65 degrees. Okay? Now, let us look at the relationship now with angle E3. We haven't done anything pertaining these parallel lines, guys. It means this 115 degrees plus this angle, it has to give me 180. It means angle E2 plus angle E3 plus 115, it has to give me 180 because of co-interior angles. Therefore, angle E2 plus angle E3 is equal to 180 minus 115, which is what? Also 65 degrees. E1 and E2 is equal to 65. E2 and plus E3 is also equal to 65. It means I can conclude that angle E1 plus angle E2 is equal to angle E2 plus angle E3 because both are equal to 65 degrees. Then E2 and E2 will cancel. I will remain with E1 equal to E3. Oh, okay. I hope you understood, guys, on how we have arrived to this problem. Okay. Now, let us look at the last example so that I will make sure that you have understood this principle. In the diagram, O is the center. Wait a minute. There is O is the center. Look for the radius. There is the radius OC and OB. It means this angle is equal to this angle. We look for the angle at the center. There is the angle at the center will be twice the angle at the circumference. Okay, since I have this 51, it means I can be able to find this angle. Then this dish. BOD is the diameter. BOD is the diameter. Look for semicircle. There is a semicircle at the top. Look for semicircle. There is a semicircle at the top. Because BOD will prove that it subtend 90 degrees, which is semicircle. It means I can also find the base of this angle. Okay. 51 degrees, 29 degrees is also drawn such that BC is equal to 24 centimeter. BC, where is BC? BC is the whole of this length, is 24 meter, and the radius of the cycle O is 13 meter. Radius, which is OB or OA, is 13 centimeter. 13 meter is 13. And the radius, I can call this OC as my radius, which is 13 meter. Okay, let us look for 3.3.1. Determine the size of COB. COB. Wow, guys, COB is the angle at the center, which is twice the angle at the circumference. It means COB is equal to 2 times angle A, which is 2 times 51 degrees. Therefore, it's 102 degrees. Don't forget your reason, angle at center. Okay, then 3.2, 3.3.2. Determine the size of A2. Don't forget your 102. Determine the size of A2. Where is A2? There is A2. We have to state first that this is 90 degrees. It means we say DAB is equal to 90 degrees. Why? It's because of a semicircle. Therefore, angle A2 is equal to 90 minus 51. Okay, which is 49 degrees. Okay, right. Let us look for the size of angle D now. Where is angle D? There is angle D. There is angle D. Okay. We have 90 degrees, guys. We have 29 degrees, and I hope we see that we have a. Okay. It means if we can check, we have a triangle here. DBA. This is 90, this is 29. I can find the sum of this angle. It means I can say angle D is equal to 280 minus 90 minus 29 degrees. Why? It's sum of angles of a triangle. Okay, which is 61 degrees. The last one now, it is to find the length of OF. Where is OF? There is OF. Okay, we have a line drawn from the center of the cycle perpendicular to the chord. Yes, I can say yes, it will bisect the chord. It means we need to start by stating that CF is equal to FB. Why? It's perpendicular chord theorem. Therefore, where is my right angle triangle? If this is 24, then this will be 12. I'm looking for OF, and can call it X. And then we said the radius is 18. Therefore, r squared equal to x squared plus y squared. What is the reason? It's a theorem of Pythagoras. Then it's 13 squared equal to 12 squared plus x squared that I'm looking for. Then we can conclude that x is the square root of 13 squared minus 12 squared. Okay, go to your calculator. It means your x will be 13 squared minus 12 squared, which is equal to 5. It means OF, therefore OF is equal to 5 meters. Guys, it was Mr. Ntuli. Yeah? The only thing that I want to promise you is that you are great, is that you will make it. Just keep on working hard. Remember, practice makes improvements. The more you practice, the more you improve. Just continue to work hard. Don't forget to subscribe, comment, tell me which problems you want me to do so that I will go straight to those problems and then I will help you. It's from your Mr. Ntuli. Thank you so much, guys.